Okay, we're going to do some area and perimeter of circles. We're also going to get into portions of circles, which will be new. Okay, so I know you guys know how to do area and perimeter of a circle, which is actually called circumference. But we'll do a quick review. Area is pi times radius squared. And the radius is that line that starts, line segment, that goes from the center of the circle out to the actual circle. So we're going to find the area of this circle. It says Fs is r, and that is 4 centimeters. So our area is going to be pi r squared, pi times 4 squared, pi times 16. And it says leave in terms of pi. So we'll just flip that around, and your answer is going to be 16 pi centimeters squared, because this is area, in areas in square units. Okay, find the area of this circle. Leave your answer in terms of pi. This time they gave us the diameter is 12, which means our radius is 6. So area, pi r squared, pi times 6 squared, pi times 36. So 36 pi inches squared. Find the radius or diameter of the circle given the area. So we're just going to work it backwards. So use your area equation. A equals pi r squared. But this time we know A. We don't know anything else. So we're actually going to divide both sides by pi. Because you want r by itself. So we have 182 over pi. Equals r squared. Let's go ahead and calculate that out. So 182 divided by, where is pi? Okay, I can't find it, so I'll do 3.14. If you really want to do pi, you can click on the math button. And I'm pretty sure, nope. No, I thought it was one of those. I don't know where it is. So we'll do 182 divided by 3.14. And we get approximately 57.9, so we'll call that 58. Close. So 58 equals r squared. So r is going to be the square root of that. So square root of 58. So our radius is going to be about 7.6 feet. Aha, there's pi above the divide sign. Okay. All right, this time we're trying to find the diameter, but it's still going to be the same thing. Area equals pi r squared, except we'll just double that r when we find it. So 368 equals pi r squared. So we're going to do 368 divided by pi. 368 divided by pi. It's about 117.13. And I'm just going to leave that in there, and I'm going to square root that. 17.138. So it's about 10.8 is our radius. Right? Equals r squared. Equals r squared. So I square root it. So that means our diameter is 21.6 meters. Okay. So that's old stuff. You can do that. Now we have area of sectors, and sectors are pieces of the circle. Think pieces of a pie, or pieces of a slice or slices of pizza. So they come from two radiuses, two radii, and the shaded part in between those two radii. This slide here is super complicated, but it's not that hard. We're going to take the fraction of the circle, the measure of the intercepted arc, that's this right here, divided by 360. So we're finding the fraction of the circle that's shaded, and then we're going to take that fraction over the total. Like I said, it'll make more sense when we do it. Okay. So we are trying to find the area of the sectors formed by angle TOB. So we're trying to find the area of the blue. Oh, and the area of the beige. Okay. So first of all, what part of the circle is the blue part? You know what? Let me do this in blue. So it's 123 degrees out of 360 degrees. I'm going to change that to a decimal. 123 divided by 360. All right, well, it's not a very nice decimal. So this is 41 out of 120. It's 0.34. It's 34% of the circle, which means the other part, minus 1, oh goodness, that minus 1. The other part is 79 1/20ths of the circle. So we're going to find the area of the whole circle and then multiply it by this fraction. Think easier problem. We're going to find the area of the whole circle and multiply it by a half, and that would give us a half circle. So area of the whole circle is pi r squared. Our radius is 7, so pi times 7 squared. So 49 pi is the area of the whole circle. So we're just going to take the area of the whole times the part. How much of the whole? 41 out of 120. Leave your answers in terms of pi. So since we're leaving it in terms of pi, just don't do the pi part. So we're going to do 49 times 41 over 120. Okay, so we're going to have 16.74 pi.
Wait, why do you have to tell me?
And that is going to be the answer of our small sector. Small. And then we'll do the same thing for the large sector. We'll take 49 times the part, 79 over 120. So the large part is 32.26 pi inches squared. Okay, so that's our large. Now you can listen to Blue's Clues. So again, you're just finding the area of the whole circle and then multiplying it by the fraction of the circle that you're trying to find. That's called a sector. This is called a segment. It's the arched part at the top of the slice of pie. So you actually find the area of the sector and you take away the area of the red triangle and you get what's called the segment. Okay, so we're going to find the area of the blue segment. First find the area of the sector, then find the area of the triangle, then subtract them. Okay, so let's do sector over here. This is a 150 degree angle, so it's 150 out of 360. I'm just going to leave it like that. I'm not going to try to reduce it right now. So that's the part times the whole area, pi r squared. Alright, so we got 150 divided by 360 times 8 squared. Remember, we're leaving the pi. So that's 26.6 repeating, which is 26 2/3 pi. Or you could do 26.6 repeating. So that is the area of the sector, the slice of pi. Now we're going to find the area of the triangle. There's a radius of 8. 150-degree angle. Let's see if we can do this here. Okay, since it's an isosceles, we can drop the altitude. So then this becomes 75 and 75 because it's 150 split. So we're going to have to use trig because we've got to find this bottom side here. Okay, so we know the hypotenuse. We want the opposite. So we're going to do sine of 75 equals opposite over hypotenuse. Now we had to split this into right triangles because trig only works with right triangles. Alright, so I'm going to do 8 times, I'm not in the right mode. Nope. Degree. 8 times sine of 75. Okay, still in radian mode somehow. Enter.
Breaking news, Agent. A phenomenal fossil was found.
Okay.
And it's a big one. This footprint must belong to a dinosaur. But the question
8 times sine of 75.
your mission
Oh, come on.
go back to the age of dinosaurs and find the clues to solve this dino.
7.7.
Oh, no.
Our opposite is 7.7, which means our whole side is about 15.4.
You're going to need to know all about
Okay, so now I know the base. I still need to find the height.
Come on, you guys.
Now I need to find this other side. I need to find the height. So I'm going to use trig again, except this time I'm going to do adjacent. So it's cosine of 75 equals adjacent over hypotenuse. So 8 times cosine 75. 2.1. So my height is 2.1. So the area of my triangle, 1/2 base times height.
Tomato.
1/2 times 15.4 times 2.1. Nope. 2.1. So the area of my triangle is about 16.17. So now, finally, we can subtract. We're going to take the area of the sector minus the area of the triangle. So it's 26.6 repeated times pi. That's the area of the sector, the piece of pie, or the slice of pizza, minus the area of the triangle,
No.
which is 16.17. That leaves us with 67.6 for the area of the segment. 67.6 meters squared. So it's interesting that the hardest part of finding the area of a segment is actually finding the area of a triangle. Something that we've been doing forever. So, you can do this. You take the area of the slice of pizza, subtract the area of the triangle, and then you're left with the segment. Okay, so you have an assignment that goes with this topic of area of circles, circumference of circles, area of segments, and area of sectors. That will also be your assignment for Friday, the e-learning day. So if you have any questions on that, obviously you can ask in the meet today. But if you have any questions tomorrow, just email me and I will respond as soon as I can. I'll see you guys in the meet.